today we learn about hydrostatic forces on flat and curved surfaces. So this is the third chapter of fluid mechanics that is very important. The aim of this chapter is used to design hydraulic structure like dams, hydraulic gates, overhead tank, etc. So this is the very important chapter for GATE, ESE, SSC, JEE exam. This is my handwritten notes. You can download it from the description available. If you have any doubt, you can comment me below. Now we'll understand in this chapter the total hydrostatic forces. So what is total hydrostatic forces? So it is the resultant force exerted by the fluid on the surfaces. So it is the resultant force. So this is very important. It is the resultant force exerted by the fluid on the surfaces. Now there is a concept of center of pressure. So it is the centroid of pressure diagram. It is the point where the total hydrostatic forces is supposed to be acting. So this is very important. Where the total hydrostatic forces is supposed to be acting. The center of pressure is below than center of area for inclined and vertical surface, but it coincides for horizontal surfaces. So we'll learn where the center of gravity location and where is the center of area location, where is the center of pressure location. Now there are 4 cases of submerged surfaces on which the total pressure force and center of pressure is to be determined. There is 4 cases, that is vertical plane surfaces. Second, that is a horizontal plane surface. Third, inclined plane surface. Fourth, curved surface. Now first we will learn the vertical plane surfaces. So vertical plane surface means, consider this is the wall here. So here this is the wall. So this is wall. This is the black color, that is wall. And the right side there is no fluid, and the left side there is a liquid are there. It may be any fluid or any liquid are there. And here up till this there is a liquid are there, and this is known as free surfaces. Okay. And the depth of the free surfaces, that is h. The depth is h, and there is a liquid. Now here the right side on the wall there is atmospheric pressure which is acting on the right side wall, and atmospheric pressure here there is a left side on the wall. Now if you goes down, the pressure is increases, and here the pressure will be maximum. What is the pressure? That is rho into g into h. Rho is the density, g is the gravitational acceleration, and h is the height of the from the free surface to the depth. Okay. So now consider this is the wall here, and here up till that the cross section is this, that is a rectangular cross section are there, and consider the height, this height, that is height h. So here to here the height is h, and the width, that is b. Okay, b is the width. Now here g is the center of gravity. Okay, g is the center of gravity of the plate, and cp is the center of pressure which is just below the center of gravity. So cp is the center of pressure. So x bar, that is equal to h by 2. So this is the height from the free surface to the center of gravity. So x bar, that is equal to total height divided by 2, that is h by 2, and cp, that is the center of pressure. So here the height from the free surface to the center of pressure, that is known as h bar. Okay, so ap, that is pressure force which is acting on the center of pressure. Okay, now so here h is the height of the wall from the free surface. X bar, that is the distance of center of gravity of the area from free surface of liquid. H bar, that is equal to, that is distance of center of pressure from free surface of liquid. B is the width of the wall, Cp is the center of pressure, G is the center of gravity. Now we know that dP by dx, that is equal to rho into G. In previous chapter we understand that the dP by dx, that is equal to rho into G. So this is applicable for compressible or incompressible fluid. Consider it is incompressible fluid. Incompressible means that is rho, that is equal to constant. Okay, so from here if you integrate this equation, that is you get P equal to rho G into X. Okay. Now if you want to, so let's focus on this area. So here this is the plate, and this is same plate here. This is the plate here, the height of the plate from here, this is h. So this is the height of the plate, and g is the center of gravity. Consider from free surface to this point, this is the distance is x, and this is the small distance, that is dx, and here there is a small area, that is dA. So dA is the small area. Okay, dA is the small area here. So if you want to calculate the pressure, okay, so if you want to, here the pressure is P. So if you want to calculate the pressure force, that is P into area, we know that. So here dFP, FP means pressure force. dFP, that is equal to small pressure force. Okay, so if you want to calculate dFP, that is equal to P into dA. Now integrate on both sides. dFP, that is equal to integration P. So P, we know that rho into G into X into dA. Okay, so from here FP, that is equal to rho G is the constant. So rho G outside, integration X into dA. So rho G, we know that rho G is the specific weight. Okay, rho G, that is the omega equal to rho G, mg by v, m by v, that is rho into g. So omega, that is rho into g. So fp, that is equal to rho G integration x into dA. Now this integration x into dA is equal to x bar into a. So AP, that is equal to rho g, that is omega, into x bar into A. So this is very important. So this is the pressure force. Okay, so this is the pressure force. So x bar, what is x bar? The distance of center of gravity of the area from the free surface of the liquid. Okay, so here this is the x bar here. So x bar, this is the distance from the free surface to the center of gravity location G. Okay, now so this is very important. Now if you want to calculate the h bar, so if you want to calculate the relation between this h bar and x bar, so how to calculate this relation? So here AP into h bar, pressure force which is acting on the center of pressure, into h bar, that is equal to integration x into dAP. Okay, so AP into h bar, that is equal to integration x into dAP. What is dAP? P into dA. So from here AP h bar, that is equal to integration x, P we know that rho g into x into dA. Okay, so from here AP h bar, that is equal to rho g integration x square dA. So AP h bar, that is equal to rho g, and this integration x square dA, that is I0. So I00 is the moment of inertia of this surface about free surface of the liquid, and this is equal to IgG plus AX bar square. So this is from parallel axis theorem. Okay, remember this I0, that is equal to I plus AX bar square. So I0, that is rho g into IgG plus AX bar square. So from here rho g, so omega, that is equal to rho g x bar. Okay, so AP, that is omega x bar into area. So omega x bar into area into h bar, that is equal to rho g IgG plus AX bar square. So from here rho g x bar A h bar, that is equal to rho g I plus AX bar square. So from here, so rho g cancel out. So h bar, that is equal to IgG by AX bar plus x bar. Okay, so from here you can see that h bar greater than equal to x bar. Okay, so this h bar, so here this h bar is greater than equal to x bar. So in that case h bar is greater than x bar. Okay, h is greater than x bar. Okay, so now suppose this is the plate here, and this area of the plate, that is A, and this is the center of gravity location. This is center of gravity location, and this is the free surface here. There is a liquid, and this is the free surface here. So from this free surface to the gravitation to the G point, the distance is x bar. So IgG, if you want to calculate IgG, what is IgG? That is the moment of inertia of area about an axis passing through the center of gravity. Okay, so IgG, that is the moment of inertia of area about an axis passing through the center of gravity. A is the area of the plate, and x bar, that is the distance of the center of gravity of the area from the free surface of the liquid. So this is the distance from the free surface to the center of gravity. So in next lecture we'll understand what is IgG for circle, rectangle, triangle. We'll understand that. So this is my handwritten notes. You can download it from the description. If you have any doubt, any problem, you can directly comment me on the comment box, and like, share, subscribe my YouTube channel. Thank you.